Hello everyone, welcome back to our YouTube channel Team AeroTech. Today we are going to attend a webinar on International Space Station ISS. So a quick introduction about today's webinar on International Space Station. So in today's webinar we all are going to know what is ISS, history of ISS, manufacturing of ISS and assembly of ISS. Also, we will see the configuration of ISS and at last you will come to know what is the purpose of ISS. So, hope you will enjoy our today's webinar on International Space Station. But before starting today's webinar, I am requesting you all do not forget to fill the feedback form. Check out the description box and live chat box for the feedback form. Now let me clear one thing. Queries related to our webinar topic you can ping at any time. Live chat box will be open for queries. If you have any technical issue, contact our technical team and you can text your issues in our WhatsApp group also. And a good news for everyone is certificate will be provided, but there is a condition for certificate. Certificate will be provided for those who will attend the full webinar. Our technical team will monitor it. So let's start our today's webinar on International Space Station. What is ISS? The International Space Station. So let me tell you. So the International Space Station is a large spacecraft and it orbits around the Earth. And you can say it is a home for astronaut also. For example, how we have home on the Earth, we cannot build it in the sky, in the space. So it is a home for astronauts where they actually live. The International Space Station. It is a modular space station in lower Earth orbit, and you should know one thing about International Space Station is that it is a multinational collaboration project between 5 participating space agencies, and here you can see all those agencies' name on your screen. And they also work together to use it. And you should know a most important fact about International Space Station is that it is made of many pieces. And do you know it is not from only one space agency? They are working together and they are putting their pieces of the International Space Station, and because of their collaboration it is possible that they can make a huge space station in the sky. Because of one space agency it's not possible that they can work this much harder and they can create such a great and a unique science laboratory in the space. And do you know the International Space Station orbit is approximately 250 miles above the Earth, and the International Space Station is also working as a science laboratory with the collaboration of several nations, and they are working together to build it and use the International Space Station for learning how we can work in the space. So here I'm asking one question to all of you. Tell me the speed of International Space Station. You can comment your answer in live chat box and let's see whether it's wrong or right. So I think you already done. So let me tell you, it's 17,500 mph. And do you know the speed? Because of this speed, 17,500 mph, the International Space Station can orbit the Earth every 90 minutes. Yeah, every 90 minutes, International Space Station can orbit the Earth, and every space agencies are using it, as I already told you, for living and working in space, like how we can live and how we can work in the space. Okay, so it is all about what is ISS. Next, the International Space Station is a largest man-made structure in the space, and as I already told you, it was built in pieces and launched in space and it assembled in the orbit. So here we are going to look in. So if you are ready, so let's go and build the space station. The International Space Station or ISS. It took many years to come in reality, and in 1984 the United States launched a project called Space Station Freedom. And here you can see some picture of very beginning of International Space Station. And after that, in 1993, after several countries were on board, it was officially changed to International Space Station. And after that, construction began in the space station. I will show you the complete construction project, but first let's learn little more about International Space Station. It mainly used to conduct science experiment and usually 6 astronauts on board on the station, and they generally switch in 6 months. And the station is about the size of an American football ground, and it located outside of the Earth atmosphere, and this is called lower Earth orbit. And here's the high Earth orbit, and as I already told you, ISS take only 90 minutes to orbit the Earth with the travel speed of 17,500, and it's about 28,000 km per hour. Over the time, the ISS slowly lose the altitude. If nothing is done, the station eventually burn, and for preventing this, the station must periodically boosted in the space. The main participating countries are United States, Canada, Russia, Japan, and many countries from the European space agencies. Let's get to know the main part of ISS, the integrated truss structure, and it's a kind of like a backbone of the station, and it holds the solar arrays which generate the electricity. Radiator panel and other equipments and science experiments is also attached. This part down here contain the pressurized modules which measure the astronaut can live and work here in the outer space with the space suit. And Russian module, also known as Russian segment, and other side is called as United States segment, as you can see here on your screen. The different pieces of the station also called as nodes, and for building many locations around the globe, each modules launched in the space by one of three rocket, and they are American Space Shuttle, Russian Proton rocket, and Russian Soyuz rocket. Now it's time to put all the pieces and parts together once construction is started of the ISS International Space Station, and here each of these lines represent the additional and new module to the station. So now let's start from the very beginning. The first piece of the station is Russian module called Zorya. It provides power from the solar rays, and there is 4 docking point, 3 in front and 1 in back. And these docking point will be used to connect the next piece of the station, like you can see here on your screen. American node called Unity, and there is 6 docking point to connect other nodes. This is called pressurized adapter, or PMA for short. And here you can see one more satellite called Zvezda. It provides the life support system, and it also has 3 docking point, 2 in front and 1 in back. And here's the next one, Z1 Trust. It holds equipments for the station, and it is not a part of main truss, but it provides a temporary mounting place. And here you can see the PMA3, and the P6 truss is temporarily mounted on the top of this Z1 truss, and this provides much needed power to the station. And radiator panels are also installed. From November 2000 to till now, there is presence of human on the International Space Station, and America launched a satellite called Destiny, and it is also known as US laboratory, where a lot of scientific experiment and research happens. And here Canada made a vital contribution with the Canadarm2, and it's a robotic arm which can help around the outside of the station, and it's usually controlled by an astronaut. As you can see here, it can move around the station. And here you can see a quick airlock which allow the astronaut to safely step out for few hours to perform EUA, also known as spacewalk. And this is a Russian module called Pair, and it used as an airlock or as an docking port to allow visiting spacecraft to attach to the station. Now we are going to start building the integrated truss structure. And now you remember from earlier, this is the backbone of the station. And now, so our first piece is SO truss, and it gets attached top of the Destiny module. The mobile remote service base system, or MBS, is the next. Then the S1 truss was added, followed by the P1 truss, and S stand for starboard side and the P stand for port side. Each side has room for radiator panel. Now only the center one will be installed. Now ESP2 added to the station right next of the airlock. Now this is the P3 and P4 truss, and you can see P5 truss goes in ESP3 and it goes down here, and then the P6 can move to its final place, as you can see here with the help of animation. Here you can see harmony module or not too. It will be attached to forward end of the Destiny module. But first we have to do some rearrangement because Harmony has 6 docking port for the future expansion of the station. Next come Columbus module, which is a European laboratory. Now we get some more port made by Canada called Dexter. Here you can see. Now, the largest module is the Japanese experimental module, also known as Kibo. It came up of the station in several pieces, and it has also a robotic arm. Finally, we have here the S6 truss, the last of the truss segment. Now it's look little more like a station, and the solar arrays will be rotated towards the sun, and this help to generate more power to the station. Japanese experimental module has one more last addition and called Japanese exposed facility. The Russian module Poisk is very similar to the pair, and this is the first express logistic carrier, or ELC-1. This is the place to store hardware to help the station to work correctly. ELC-2 was installed on the top of the truss. Now the Triangulity module, also known as North 3, is added to the side of the unity. On the bottom side of Triangulity, small room called cupola, and this has 7 windows to see the view. Each window can be closed when they are not in use. And then came a Russian module, and it will use for storage and for the docking port, and here this one used for wastage. Now here ELC3 and ELC4, this is called alpha magnetic spectrometer, and it is used to study where a protocol such as in time or not. One more recent addition to the station called Bigelow, and it is a expandable activity module, or beam for short. So it was all about the construction of International Space Station, and I hope now you have a better idea about the construction of International Space Station. Now I'm going to tell you some interesting fact about International Space Station. So here the first one is still 240 individuals from 19 countries have visited the International Space Station. The second one is the space station has been continuously occupied since November 2000. And the third one is an international crew of 6 people live and work while traveling at the speed of 5 miles per second, and the travel speed is 17,500, and it orbits the earth every 90 minutes. As I already told you in previous animated video that with the speed of 17,500, the International Space Station can orbit the earth every 90 minutes. And the next point is in 24 hours the space station makes 16 orbit of the earth, means it can orbit the earth 16 times in a day. Okay, now traveling through 16 sunrise and sun. And here is the next one. On orbit software monitor approximately 3,15,000 sensor, ensuring station and crew health and safety. And if we are going to talk about how the systems can be controlled there, so with the help of more than 50 computer, it can control the system on the space station. And in the International Space Station, US segments alone, more than 1.5 million lines of flight software codes run on 44 computer communicating via 100 data network transferring 4 lakh signals, like for example pressure and temperature measurement, value, position, and etc. So now if we are going to talk about International Space Station size and mass, then you will come to know that a pressurized module length is 167.3, means 163.3 feet, and in meter it will be 73 meters. About truss, means truss length is 357.5 feet, means in meter it will be 109 meters. And the solar array's length, so if we are going to see the solar array's length, then it will be 239.5 feet, and in meters it will be 33 meter. If you are going to talk about the mass, then the mass of the International Space Station is 9,25,335 pounds. It means in kilogram it will be 4,19,725 kilograms. And if we are going to talk about habitable volume, then it will be 13,696 cubic feet, and in meters it will be 388 cubic meter, not including visiting vehicles. Here we are not including the visiting vehicle in the volume. And now when we are going to talk about pressurized volume of International Space Station, then it is 32,333 cubic feet, and in meter it will be 901 6, means 916 cubic meters. And here beam, means as I already told you, if you remember in previous animated video, beam and the full form of beam, so hope still you remember that one. So it is 32,898 cubic feet, and in meter it will be 932 cubic meter. And we are going to talk about power generation. Then there is 8 solar arrays provide 75 to 90 kilowatts of power, and it is enough for the International Space Station, and the line of the computer code is approximately 2.3 millions. So now we are going to talk about history and timeline of ISS, International Space Station. So it took 10 years and more than 30 missions to assemble, and it is the result of unprecedented scientific and engineering collaboration among 5 space agencies. And as you already know the size of International Space Station, so it is approximately of the size of football field, and 460 means 460 ton, and it is about 4 times as larger as the Russian space station Mir, and 5 times as larger as the US Skylab. So once the idea of a space station was science fiction and existing only in the imagination, because nobody knows that it will come in reality and we will build a space station in the space which will always help us in every ways. And the first station was created in 1969 by linking the two Russian Soyuz vehicle in space, followed by other space station and development in the space technology until construction began on the ISS in 1998. And it is added by the first reusable spacecraft ever developed by America, called American Shuttles, and the first component which is launched by the US, called Unity. So now I'm going to show you a video. It is a tour inside of International Space Station, and what we learned in our previous animated video, you can see all those parts from inside, and this video will clear a lot of doubts. So watch this video.
Okay, here we are at the very front end of the International Space Station. This is the forward end of Node 2, and this is right behind this hatch is the PMA, pressurized mating adapter to which the space shuttle docks whenever the next space shuttle comes. You can see we have our flags up here at the most forward part. It's a 15-nation partnership, this International Space Station. So we'll start with the Node 2. We will stop at the Kibo module here, the Japanese pressurized module, and the Japanese logistics platform. We'll stop back there in a second. We'll take a look in the Columbus module, pride of the European Space Agency, and our pride too. And then you can look down the stack and you can see several other modules, and even into a little bit into the functional cargo block, the FGB, and then the service module. So it's a really big space station that we got. Welcome to Kibo. Please enjoy and relax in this brand new, the most spacious and quietest room in the ISS. You can see here, this is the SIBO rack, which is for cell biology. And then we have a fluid rack, Urutai. So these are the two main Japanese science racks that are up here now. There's more that are coming. Let's take a quick look out the window before it gets dark outside. We're going around the world every 90 minutes, so we get to see a lot of sunrises and sunsets. Oh my goodness, it's beautiful out there. So this is looking out the port side of the space station, and we're actually also on the front side, so front port side of the space station. And let's take a look what we can see out there. We can see the robot arm I was talking about, the GEM RMS. Those orange things are the solar arrays on the port side. And you can see we have a full set, and 15A STS-119 is going to be bringing up the last solar array on the starboard side. And take a look, there's our beautiful blue planet there. And looking at this and where we are, I'd say we're over the South Indian Ocean. You can actually see some icebergs down there, so we're actually probably between Africa and Antarctica. You can actually see the different shades of the blue water. Okay, so now fly with me. We're going to go to the Columbus module. Here we are in the Columbus module. You can see it's also spacious. It's also cluttered because it's a great place to store things or temporarily stow them. It's not going to be this way forever. We're going to have it nice and clean pretty soon. We're flying back to Node 2. We'll take a quick look what else we have here. We have my work area. It's a little bit cluttered right now, but this is kind of my desk. It doesn't sit out horizontally, but it has everything I need on it. This are my crew quarters right here. You can tell it has my name on it. And in fact, I can give you a tour real quick of crew quarters. This is what it looks like inside. There's a fair amount of room. We'll get has a standard space station light on it. So now we're going into the Destiny Laboratory, headed aft on the space station. And there's my crewmate, Sandy Magnus. She's getting her exercise in for today. This rack is the oxygen generation system, and we have a few too many things on this rack, and we're in the middle of cleaning it off, not to interfere, but you can see oxygen, we're making oxygen, and when we make oxygen, we're breaking down water into hydrogen and oxygen, and the oxygen comes right out here. The water we're making either comes from the condensate from the air conditioning system, the water that's in the air, or urine. So this is a really neat regenerative life support system. And now we're going to go back into one of the first modules, Node 1, which is also called Unity. This is our pond, or wall of water that's down here. We have different kinds of water, and these are called contingency water containers, CWCs. And you can see different kinds. There's water that you can drink, and water that you can use for other things like flush water or generating oxygen. Now here's the airlock. As we go, the Quest airlock. This crew lock is a hatch that goes outside into space. So you can see that hatch right there. In the meantime, we're kind of storing EVA related things here. You can see this is a safer, which is a kind of a jet backpack that we wear on the outside of our spacesuits in case we get separated from the spaceship. We can fly our way back in. I remember being a Capcom on STS-96 when I first saw these signs. That's pretty amazing. And we're floating into the Russian side of things. First and foremost, we are now in the pressurized adapter part of the functional cargo block. We call it the GAA, and it's also a docking port down below. As you carefully look down below, you can see the hatches, and inside what you can see in front of us is the docking mechanism for the Soyuz. It's very compact and not a lot of room. Makes it very efficient. Now Yuri's been busy unloading the Progress. We just finished an EVA, so things here in the functional cargo block are very functional right now and very cargo-y. So you can see things are just really full here in the FGB. As we leave the FGB here and go into the docking compartment. Docking compartment is another one of those vertical looks, and it's a kind of a misnomer. It's not just docking compartment, but it's also a airlock. So Yuri and I went out in these two spacesuits a few weeks ago and went into open space and had a spacewalk. Continuing on down through here, we'll stop here on the way back, is our Progress cargo vehicle. The Progress is a cargo ship, unmanned, uncrewed, nobody driving, and has the same kind of docking compartment. It's very much based on the Soyuz design, except it doesn't have any re-entry capability. And we're going to take a look outside. And this is the hatch that I opened up and went outside for a spacewalk, and we're looking aft on the space station. There's a ladder, some solar panels. We're looking at the service module, Zvezda, and looking at our beautiful planet Earth. Let's see if we get a nice little view here of Earth. A little small treat, because no tour of the space station would be complete without it. Last but not least, in the service module, Zvezda, which means star. It's the heart of the space station. It's where we used to have the only place where we could create oxygen and live with the carbon dioxide removal system, as well as a place to eat and sleep. There's my crewmate, Yuri Lonchikov, exercising on the treadmill with vibration isolation system, the TVIS. So this is our eating area. There's our table, and we're just getting ready for lunch. There's our water dispenser right there, Russian style, and our controller for the water dispenser. There's Yuri's room off to the side. You can see he has a sleeping bag right there hanging on the wall, and a computer right here so he can call on the telephone and write email and read books, and relax in the evenings a little bit, because we have long days up here. This is a surprise visit that you guys are paying on us today, so things aren't cleaned up, but they're real. This is exactly how we work and live in space. And that'll wrap up the tour. This is the International Space Station. A very good example of what human beings can do when we work closely together.
Don't forget to subscribe our YouTube channel, and also you can check the description box for our social media links, and you can join us for further information about certificates. So stay tuned with us and fill the feedback form, and you can get the feedback form link in the description box, comment box, and in the live chat box. So do it now, and have a great day.